All right, guys, we have another one to add today. We're going to look at midpoint and distance again. So I know we already talked about this when we were talking about segment addition postulate, but we're now going to talk about midpoint and distance a little bit differently. So rather than looking at midpoint and distance on a line somewhere floating out in space, we're going to take that line and we're going to put it on a coordinate grid. So thinking back to Algebra 1 a little bit last year when we were like graphing lines and stuff. So we're on a coordinate grid. We're going to draw a line segment and we can talk about how long that line segment is, or we can talk about where the midpoint of that line segment is. Lots of fun things. So in our table of contents right here, I know it looks like the last one, but we're going to have actually one more after this. Oh, again, I need an editor. It's so bad. So we're going to put midpoint and distance. That is going to be on 12 and 13. And then we're going to have to add another one, not today, but later this week. We'll add one more. And then we'll talk about taking a test. Okay, so we'll turn to page 12 and 13. And on page 12, I'm not going to put anything just yet. On page 13, we're going to take that last notes that we have in our notebook, which I know, again, feels like we should be done, but we got one more left after this, and that one I just don't have a printout for. And so we're hopefully looking at this one here. And that one, again, we're going to fold the short edges into the middle so that we have like French doors. And again, if we want to be cute, we can cut out right in the middle here to get little doors like that. That one I'm going to tape onto page 13. Okay. Now, I have to preface this always with, I will give you the formula. There is a formula for it, but there's also sneakier ways to do it too. When I say sneaky, like for some people, it's easier to count things to figure them out rather than having to memorize a formula. Both ways are good. I like both ways. I low-key kind of like counting better than memorizing a formula, but some people are really good at memorizing and I'm just not. So I'm going to show you both ways and you choose whichever one you like best. Okay, so actually let's look at the distance formula first. We've actually already talked about this guy a little bit when we were doing segment addition, like I said. Okay, so if we are on a number line, and I think I actually gave this formula to you in class, we want to find the distance between something, or like this is low-key length. So distance or length means the same thing. We're going to take the larger number and subtract the smaller number from it. But then we have to be careful because distance or length always has to be positive. And so we put these absolute value bars around it. It doesn't really do anything aside from the fact that if I somehow subtracted and got a negative number, I'm going to take the absolute value and make it not negative. Make sure it's always positive. Okay, so if we open that up and take a look up here, let's give these points some letters just because I can't even. So let's say that this is A, B, C, D, E, F, G, H right there. And let's say we want to first find the distance of AB. Our formula says we are going to do larger minus smaller in absolute value bars like that. So between A and B, the larger number is 9. So we'll do 9 minus the smaller number, which is 2. 9 minus 2 is 7. The absolute value of 7 is 7. And so our length or the distance is 7. Okay. Next, if I'm going to find this distance of CD, again, we're going to use our formula, larger minus smaller, absolute value bars around it. the larger number here is 2 minus the smaller, which is -2. And when I have two negatives next to each other like that, they meld together to become a plus. And so we really end up with 2 plus 2, which is 4, the absolute value of which is also 4. Next, the length of EF. We're going to do larger minus smaller. The larger number here, you have to have a chat. They didn't tell me that it's right in the middle of 1.2 or 1 and 2. They didn't tell me that it's the midpoint. They didn't tell me it was in the middle, but I'm going to tell you right now, it's in the middle. So it's 1.5, okay? We shouldn't normally guess. We're going to go with it's in the middle right now. So it's at 1.5. That's the larger. The smaller is -1. And again, we got those double negatives going on. So we're actually going to add. So 1.5 plus 1 is 2.5. Absolute value is still 2.5. Oh, I should have done one where when we subtract, we still get a negative. And that could happen if you are fully in the negatives. Like if both of your points were fully down here in the negatives, that's where you might end up still subtracting and get a negative rather than a positive, and you'd have to take the absolute value. Last but not least, so we got GH. We're going to do larger minus smaller. The larger number here is 2.5. You're going to subtract off a -2.5 because that is between 2 and 3. So really we're going to add for 5. Now guys, the easy way to do this, rather than following a formula, is literally just count. You don't count the lines, you count the spaces. So 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4. Or 1, 2 and a half. Or 1, 2, 3, 4, and then a half here and a half there for 5. So it's kind of easier. Now, let's stay with, well, no, let's go over to midpoint. Midpoint on a number line is also pretty easy. I think we maybe talked about it in class. I'm not exactly sure. But if we did, we just talked about how you could count and find the middle, which count to find the middle is the go-to way for me. But you can use a little formula. And to use the formula to find the midpoint, we have to do larger plus smaller and take half or divide the whole thing by 2. Right? So if I add them all up, I'll get the distance in between, or like how much total there is, and then I take half to find the middle. Okay, so if we try that here with our lines, we're going to find the midpoint of AB. I'm going to do the larger, which was 9. We had larger plus smaller divided by 2. Oh, my freaking hell. So 9 plus 2 over 2. Now we have to add first on the top. And so we're going to end up with 11 over 2, which is 5.5. I would leave it 11 over 2, but 5.5. And then we can go plot it. So I go to 5.5 and plot it. And I'm going to call it M1 for midpoint 1. And doesn't that look like it's in the middle? It totally looks like it's in the middle, right? And again, we can just count, boop, boop, boop. So what I do is I start from the ends and I count one space in at a time. So I get to here, 1, and then I go 1 again, and then I go 1 again. And that's where I need to meet in the middle. So that's why I end up in the middle of a square right there at 5.5. So we can count, boop, boop, or we can use our little formula. So if we find the midpoint of CD, we're going to do large plus small divided by 2. So the large number here is 2 plus the small number here is -2 all over 2. Now 2 plus -2 is 0. 0 divided by 2 is 0. So my midpoint is located at 0, which if I plot that on there as midpoint 2, that looks right. And again, if I count, boop, boop, we get to the middle. Again, if we try this on EF, we do the larger number, which is 1.5, plus the smaller number, which is -1, and divide by 2. So really what I'm doing here is kind of subtracting, but I'm adding a positive and negative number. So 1.5 and a -1 is half, or 0.5. And I hate decimals and fractions missing. This is mixing like this. This is really stressing me out. But if I take half of a half, like think about baking. If I have a half of a cup and then I need half of that, that's a fourth. Kind of wild. And I think it makes sense. So I can count a full 1, and that will put me at 0 for here. But that's going to put me at half right there. And to meet in the middle of 0 and half, hopefully we all get and understand that that should be at a fourth. And then last but not least, we got the midpoint. Oh, I didn't plot it. Boop. Midpoint 3. GH, we are going to add the 2.5 and the -2.5, and then take half. And again, those are opposites. So that's going to be 0 divided by 2 is 0. And if I plot that boy, that looks so right. And again, if I travel a full 1 here, that puts me in the middle again, And then if I go half more on each side, I'm right in the middle. So I have to count by equal amounts to get there, but I still get there. Now, if we are not so lucky to be on a number line, but we are in a 2-dimensional space, so on the coordinate grid, or on the coordinate plane, again, there are formulas. I will give them to you now. If you like to memorize formulas, you may do that. There's also a way to count though. So the distance formula is a big long square root, which you may have learned this last year. You are going to subtract your 2x values, doesn't matter who from who, and then you will square it. You will subtract your 2y values, doesn't matter who from who, and then square it, add them together, and then square root the whole thing. And that will tell you how long your line is. That's why I don't like that formula, because it's kind of scary looking. So we can use something else instead. So if I want to find the distance of AB, I first want to draw it. So I'm going to draw in my line. And I can use my formula. So the point A, I have to find it out in space, is at 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it's at 4, 6. Point B is at -8, 4. Okay, so then using my formula, I can just subtract my x's, and they're already lined up to do this. So that's super nice. You could actually just do it that way, where you have these stacked and now you subtract. So x minus x, because these are our x's right here, and a big old square root. My x minus x is going to be 4 minus -8. So I'm really going to add for 12, and then I square it. Then I subtract these two for 2. And then I square it. Now I have to square them. So 144 plus 4 is 148. And I don't know the square root of that. It's like 12-ish. But I don't know. So the way I like to do it actually uses something that we're going to talk about a lot later in this class. But I can show it to you now. So if I count the slope, so if I start at B and count the slope of my line, so I rise up 2 and run over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That 2 number and that 12 number, I get much quicker. So rather than having to find the points, subtract, I just count my slope numbers instead. And we're using something about a right triangle here that maybe you remember. So you kind of have to memorize a little bit of a formula, but if you do slope, then you get your numbers that you have to square, then add, then square root. Okay. So another example like that if I was going to find the distance of BC, again, I want to first draw BC, my line segment. This time I'm going to do it a little backwards. So I'm going to do my little shorty cut way. So I'm going to count out the slope. I'm going to start at B because it's leftmost, and I would have to like go down, which if I count those squares, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I have to go over 1, 2, 3, 4, 5. I can just use those two numbers in my little formula. So the up and down number is your y number, the side to side number is your x number. So we're just doing the square root of 5 squared, my side to side number, plus 12 squared, my up and down number, my y numbers. And so then I square each of them. 5 squared is 25. 12 squared is that 144. When I add them up, I have 169. And the square root of that is actually 13. So if I can do it, I do it. If I can't take the square root of it because it's going to be a nasty decimal, I leave it. There are some things you can do with it, but I don't want to talk about them now. So then last but not least, we have the distance of CA. And so if I draw in CA, my line segment, we can do it either way. I like to count. I just feel like it's faster. I'm going to count on my little slope triangle here. Now I could go up, but it's going to kind of cut through here. If I go over and up, it's kind of the same. So I'm going to go over until I get to A, and then I'm going to rise up to get like this slope triangle going on, and then I'm going to count each one. So we got 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3, 4, 5, 6, 7, 14. So we have our two numbers that are going to be our x numbers and our y numbers. So we're going to do the square root of 7 squared plus 14 squared. Now the other thing that a lot of people like to try to do is square root right now, but you have to follow order of operations, and I have to do the exponents, then I have to add, and then I have to square root. And that's because these are low key in parentheses. Like you have to do that first. You can't just square root the squares away. So we get 49, 196. And when I add that up, oh my gosh, big numbers. We get 5, carry the 1, 5, 255. I don't know the square root of that. I'm going to leave it like that. I don't think I know the square root of that. I think it's a decimal. Yuck. Now, the midpoint. So the midpoint formula on the coordinate plane is kind of similar to our midpoint formula on one line. We just have to do it twice now. So like I added up and divided by 2. I do that here as well. I add up my x's and divide by 2. And then I add up my y's and divide by 2. And it doesn't matter the order that you add them in. You just have to add up the x's, add up the y's, divide by 2. Okay? It's not a bad formula. It's fine. But you can also do it by counting. So if we take a look at AB, I had those points written down over here. So we were at 4, 6, and then negative 8, 4. Okay, so using my formula, I can add up the x's. So here I just add instead. And so 4 and negative 8 is negative 4. And 6 and 4 is 10, but then we have to divide by 2 on each. And so my midpoint is going to be at negative 2, 5. So if I go plot that, negative 2, 5, 1, 2, 3, 4, 5. If I look at that line, that's totally believable that it's right in the middle, don't you think? So here's the county way to do it. If I don't want to do a formula, if I have this slope triangle already going on, rather than traveling the full slope formula, the full deal, like up 2 over 12, I can just go halfway. I go up 1 and then over 6. 1, 2, 3, 4, 5. And I get right there. And that's so cool. It's so cool. And so because I already have all those slope formulas drawn on here, for BC, instead of going 12, 5, I'm going to go 6. 1, 2, 3, 4, 6, and then 2.5. 1, 2, because that's half of 5 is. Boom. It's right there. It's believable. It makes sense that that should be the midpoint, but now I have to write it down. And so that point is located at negative 1, 2, 3, 4, 5.5, comma, down 1, 2, so negative 2. And again, it will be right in half because we're splitting these things in half. It's midway. So that makes sense. And then same thing for 7 and 14. Rather than traveling over 7, I'm going to go 3.5. So 1, 2, 3.5. And then rather than going up the full 14, I'm going to do 7. 1, 2, 3, 4, 5, 6, 7. So right, yeah. Oh, I feel like, should I be up one? I feel like I should be up one more. Did I not count right? 1, 4, 5, 6, 7. Right there. Then I just have to write that point down, which is at half over and down 1. Ba-bam. Now I was going to have you guys try some more on page 12, but I feel like this video has been long enough already. So 12 might just be blank, and that's okay. So let me know if you have any questions. Hopefully it goes all right, and hopefully you love just counting.